So in order for our application and our database tier to talk, we need to define how that's even possible, right? We've said that these are two very different things. Regardless of what high-level language you're talking, if we're talking about a relational database with a relational model, how they work is very, very different. So whether it's a web application, a native one, a mobile app, all of these things that talk to databases must be able to connect and communicate with it. It is not native to high-level programming languages to do that. So there's a bunch of ways that that is possible, and that is what we want to explore here. The first thing we have to talk about, and we've mentioned this before, but I want to give it a formal definition, is how it is different, right? And we refer to that as the impedance mismatch problem. So the idea is here that the data model of SQL in relational, not necessarily in NoSQL, but we haven't, other than in the early classes, haven't been talking NoSQL. We've spent the vast majority of our time in relational. Is that this data model, the relational data model, differs so much from the model of the languages that you're going to be using at a higher level. The application, I shouldn't say higher level because SQL is actually as high as it gets, really. But the application tier. So the application tier, it could be, say, let's rewind back to the pre-object-oriented days. So just flat out C, not even C++, right? You had obviously your regular, what you would think of like integers and real numbers, like doubles, floats, etc. You had strings, of course, or character arrays. And then, more complex, really you had like structs, right? So you could, create something like that to have a more complex data model, but there wasn't objects yet. And then you have on the other side, you have the database, and the database is, it's a table, it's a relation, and it's a set of records. It's a set of tuples is exactly what it is. So these things were inherently different. And then even as you get into the object-oriented world, you do have more similarities. So, but they're still very different. I mean, you can have a list of tuples or, an array list of, objects, and that's what we do nowadays in an object-oriented programming language. But you still have to map what you want out of the database into that model, and it is not inherently going to work automatically for you. Now there are tools, and we're going to get more into those tools. I talked a lot about this in the coming week, called object relational mapping tools. They help you kind of automatically do this join, right? But it is inherently not there. And before we get to that point, we gotta talk about how we even communicate between these two things. What is the differences? How do we get our programming languages to talk to our database? How do we cast these differences? I mean, like, look at varchar, right? So there is a text field, which is also equivalent to a string, but there's varchar, right? So, most programming languages have a string. Varchar sets a certain amount of space that you can have. Like, there's very big differences there. So we have to kind of address those and understand them before we can get into the more complex, well, how do we solve this in the real world using like object relational mapping, right? So how do we find that best fit? Before we can even figure out the best fit, we have to figure out how these two things talk, right? I'm going to don't worry about this example here. This is very, very high level at this point. I'm going to give more specific level when we get into like JDBC drivers, that kind of stuff. I'll give actual connection examples. But the basic idea for now is that because these two things are different, we need to set up a way for them to talk. There's actually a few ways we can do this, and I'm gonna iterate through those ways in a little bit. But for right now, I just want you to know that the act of having the application code talk to the database is a connection. What you gain out of this is the ability to send commands, just like you do in a database client. to the database to retrieve, send SQL and retrieve answers, usually in the form of what we would call a result set. And that's universal no matter how we choose to do the actual talking. I'll talk about those methods, but we need a connection. Another term I want to put in here because it's important, and we're talking about connections, is this idea of a connection pool. You'll often hear about when you're talking about an application connecting to the database, you'll often hear we're talking about a connection pool, and there's lots of tools for this nowadays, especially like in the Java world and other places. But more high level, more abstract, a connection pool is just a cache of connections. So because a connection can only do one thing at a time with the database, and it would be very slow if you have thousands of clients for your application and they're all asking the application questions, and the application then has to wait for this one connection to the database. So because connections require a lot of memory and some setup and teardown time if you have to create them and destroy them, a commonly used design pattern here is to create what's called a connection pool. It says cache of database connections. It holds on to them, and if they're not being used, they just kind of wait around to be used. And then as people come in, it uses them to, basically think of them as like open doors that you can, walk down to get to where you want to go. If it needs to create more, it can. That there's a little bit of a cost in processing power and memory, of course, to create more, but it can create more, just like it can destroy them if it finds out it doesn't need them. But the idea here is that one connection isn't enough, so we're going to have this dynamic thing that can expand and contract called a connection pool that keeps a whole bunch of these. Another term you'll hear commonly, and this is more on the database side than the application side, but you'll hear of a term cursor, and I'm not honestly going to talk much more about cursor after this. The book kind of talks about it in detail, but nowadays we don't necessarily think about the cursor so much as the application developer when we're talking to a database, but I do want you to know what it is. The cursor is basically just a control structure that is monitoring our traversal through the records of a database. As you probably noticed, because you're using SQL and it's such a high level dynamic language, you're actually getting back like result sets and stuff, like it's really just a tuple at a time, right? And you can iterate through those, but you need this pointer, and the pointer is this cursor, and that's what it's referring to. So when you're thinking about, and we'll see this in action in a little while, when you get a result set back in your application, and you're going through it row by row to kind of create objects from what was returned, you're using the cursor to move through it row by row. And that's really what it is. It's this pointer. Every connection has one cursor, but each connection, if it's serving different clients, can have its own cursor, right? So if I'm looking at those user records, for example, that we were talking about in the previous video, and I'm on page 4 looking at records 40 to 50 or whatever it is, that's where my cursor is pointing, right, to the end of row 50. But somebody else looking at the same table on their own connection in the connection pool, their cursor might be pointing somewhere else completely in the database, right? So it's just this control structure that we use to kind of get information across and know where we're looking in the database. So why do we go through this madness, right? Like, was it ever thought about that maybe we could just have like a more powerful SQL, and we wouldn't need an application programming language, and we could design the whole thing in one place? Or is SQL even necessary and relevant, and could we design everything in the higher level programming language and talk to the database store directly, right? Well, the problem with that is multiple, and there are actually things in the NoSQL world that are closer to the latter. But the important kind of thing to drive home here is SQL is this kind of universal thing that mediates the middle. So if I'm using C or Java or .NET or Python or whatever, I can still connect and write SQL queries. Now, granted, and then it's a database agnostic on the other side too, right? Or at least close to it. I can connect to SQL Server, I can connect to Oracle, I can connect to Postgres, I connect to MySQL. Don't connect to Access Database. Just don't do it. But whatever it is, it's that medium, it's that abstraction that means I don't need to have to write a specific thing for each one of those programming languages, etc. Right? So it works both ways. It serves as that universal abstraction that works in between, and it serves a really good purpose because, as we mentioned, result sets are just multiple tuples. They're just multiple rows of data. And except for like a spreadsheet, that's really not the model that we use in higher level programming languages. So they're intrinsically just two different things. And it makes sense to have tools in our toolbox to accomplish both things that are purpose built. SQL is purpose built for dealing with the data, and your high level programming language is purpose built for the domain that you're working in. In fact, that's why we have high level programming languages to begin with, because if we were all programming in assembler for every task, we'd be at it all day. But having a high level programming language that gets compiled down into assembler means that we can build a programming language like R that's really good at statistics, or Python that's really good at AI and a whole bunch of other stuff. We can build purpose-driven tools for the job. And that's why we're here, right? That's the whole purpose. So that's the basic idea. Now, there's three ways that I'm going to talk about that we can actually connect our application to the database. So the book focuses a lot on the first, and a lot of that is because of the time of when it was written, and they focus a lot on like C, but they do talk about like some more modern approaches later. But to be honest, the first one is important to kind of know, but it's not prevalently used. But to be fair, what we're going to spend more time on, the driver provider CLI part, is a little bit of semantic sugar of the first one. There's not, other than the fact it's library driven, it's not all that different. There are some differences, but we'll get there. And there's also stored procedures in the middle. There's this idea that we can actually move some of the logic into the database. We'll talk more about that when we get there. So the first one here, embedded SQL, was really popular, especially before object-oriented programming languages. And the reason why is because now with object-oriented programming languages, at least we do have data structures in the object-oriented programming languages that, while they're not exactly the same as the tables, they are pretty close. So we still need to cast and map what we're going to do, and we still need to think out like, okay, so like user roles and roles is a great example. If I want to query a database to get all of a user's roles, when you think about that in object-oriented programming, right, you could do that a bunch of ways, but a common way would be to have a user object, and in that user object, there might be an attribute that is a list of roles, right? So notice there that there's an object, a complex object, that has as one of its members another set of complex objects, but there's no many-to-many table, right? This is intrinsically what I was talking about how the data structures are just different, right? Object-oriented programming languages give us the ability to create something very similar, though, but there's no table in the middle there. I mean, you could do it other ways where there'd be something more similar, but that's the natural way to do it. So that, though, does require this kind of interpretation, but it's pretty close. But if you go backwards in time to like C, before object-oriented programming languages, you didn't really have as easy a transition. So there wasn't as, it required a little bit more coding and a little bit more kind of for loops and iteration and creation of things, and it's just it made more sense to just do it this way, or at least looking back on it, it feels that way. You basically, what this is you would have a preprocessor, just like any other time you have a header file in C. or annotations in Java or anything like that. What's dealing with that is a preprocessor. So you haven't taken compilers yet. The preprocessor runs before compilation. It looks for anything that needs to be preprocessed, and it basically recreates it into high-level native code. So if it's C, it creates it in C. So if it's a library, it brings it in. If it's an annotation, it does whatever it has to do to make that annotation actually happen in that place. And then the compiler compiles everything, right? And that's how embedded SQL works as well. And you can see example. I'm not going to put the examples up here because it's not as prevalent today, but there are plenty of examples in the book. So if you want to go through the book and look at those, please, it'll give you a good. They really are good examples. They do a really thorough job on the embedded SQL there because, I think in the authors' lives, I think this was a very pertinent way and common way for them to interface with the database. So they do a really good job of that. And the way it worked is to pass information back and forth between what would be preprocessed, the embedded SQL, and your regular code, you would use these shared variables. So, and they talk about how they're notated in the book as well. But basically, that's how it works. So the embedded code would have the SQL statements. The SQL statements would save the information into these shared variables that you could then reference. It's very common to like a JSP or something like that, where you would like pass information to it, and then within the HTML, that is in the JSP, you can reference the Java variable, right? Just give it the right annotations and it would be fine. And that's the same idea. So you would then use those shared variables in your code outside of the embedded SQL block, right? And that's how that worked. This is not as used today. Now, stored procedures is another alternative. So instead of, this one's different, and a lot of, the book does talk about this, but I think it glosses over it a little bit much for my taste. Instead of having the business logic more in the application, there is an alternative. And this was part of the SQL standard. I think it was 2003. And then Oracle, Microsoft, IBM, all the major database vendors created their own implementation of this. For Oracle, it was PL SQL. For SQL Server, it was Transact SQL. I think IBM's was called, it was very similar to Oracle. I think it was like SQL PL or something backwards. So the idea here is that we're going to move that logic, that iteration, that if statements into the database. We're actually going to have, and it's going to store it in the database, which is even weirder and cooler. We're going to take some of that logic, make it into a function that we call in the database. Like you're literally going to, from your application, say, call the database function X. The database function is going to have all of the logic that we just discussed, that we would have put in our application in the embedded context, and that we will talk about again with CLI. And it will just return to me some value that I'm going to use, right? Now, the interesting thing about this is that what is it going to do to your load situation, right? So imagine you create a stored procedure to work with map cushion, and the stored procedure is to do that really heavy lifting that I keep mentioning, which is to locate a person based upon the device's beacons that the device sees and the signal strength of the beacons that the device sees, right? And knowing the locations of those devices. So all of that logic, querying the beacon tables to find out wherever the beacon floor relationship is, where the beacon's actually located on the floor to find out its position, querying the table that has the information about what is the last known signal strength of all the beacons and what beacons the devices saw, and all of that information now has to be done directly on the database by code in a stored procedure. And then it's going to do all the math to figure out where you're located, and it's going to send back a simple location in XYZ space in altitude, longitude, latitude. And the interesting thing about that is I've moved it further down the stack. So that means on the good side, if I have all kinds of applications that I want to connect to that database, which is very common, by the way, it might be, you even think in the school space, right? Like you have things like iLearn that knows your student data, and MyMaris knows your student data, and Banner knows your student data, your register. So how interesting is it to take that business logic and push it all the way down to the stack to that first bottom tier, because then everything on top of it can call it, right? You don't need to recreate that logic anywhere. That's interesting, but the flip side is the load, right? Because now if the database is doing all that, it's doing the function of the application and the database and all the memory associated with everything, and it's got to manage it all, right? So you've just increased that database load by quite a lot. And this is something I actually ran into in my own life, in my previous life when I actually had to do work. This can add up to a lot. So something to consider. You can move the logic off to the database in these examples. The more what people think of as lightweight databases don't provide as much here. So like Postgres, MySQL, that kind of stuff. It's not as robust in the stored procedure area as say Oracle with PL SQL. But if you are working with something like Oracle, this is definitely an option. And there's pros and cons here. So that's kind of the lowdown on stored procedures. That's not where I want to focus, though. Where I want to focus is this, because this is what we do nowadays most of the time, and where I'm going to focus my energy, because I think this is where you guys will have experience either already or hopefully will soon. So CLI, call level interface, is basically a little bit of semantic sugar, a little bit of newer approach to the embedded. It basically takes everything that you would have done inline and embedded and makes a lot of it available in a library. And this library is commonly referred to as a database driver or provider. And you probably know it by names like JDBC Connection or ODBC Connection. PHP has pair, right? So these are all examples of a CLI. You remember your application is a client of the database, right? So basically the driver is this client-side adapter that's installed on the client machine. It's usually provided for the language and the database combination. So if you want to connect to Oracle and you want to connect from Oracle or to Oracle from Java, say version 9 or 10 or 8 or whatever, you get the correct JDBC connection for Java 8 to Oracle whatever, right? And there's going to be a very specific driver oftentimes for that specific connection. What this driver gives you, what it is a library of Java code that you call and you pass it SQL statements. Quite literally, you can say, I want to select star from users, right? And it's going to know how to carry out your command and do it on the database. It basically encapsulates that for you. And this is what we do today. This is, by and large, how it looks. And if you're curious to see like a comparison, I'm going to have code snippets in here of this part because it's what I consider relevant. But go back and look at the embedded code in the book in chapter 9. And you'll see the difference of what the old way looked like versus using these drivers, right? It also meant that it was compartmentalized to that library so that when a new database version came out and you upgraded your database, all you probably had to do was update your database driver to talk to the new version. And you didn't have to go into your code and rip that apart because your code was just calling that driver. And if all is well and you update that driver, then you can still connect and everything is good. So that's the idea behind the CLI. Some terminology behind it. Environment is just a set of connections basically to the database server. Generally speaking, you don't think about the environment much. It's kind of part and parcel. I'll show you that when we get to the code. You just kind of have the environment because you've instantiated the driver. That's kind of the environment. Then you create a connection, and we'll look at a specific example of that. I think maybe even more than one, where you actually say, okay, I want to connect to my Oracle database, and my Oracle's database name is X. I'm going to connect with user Y, and user Y has password Z, right? And I know that it's running on this port and it's running on this host, because remember, these are probably going to be on different machines, right? As we saw in the last talk where we broke it up into sections, your database server is going to probably be running on one server and your application server on another, etc., and maybe even more. Statements are the individual SQL queries that we're going to pass through the connection to enact on the data store. And what we're going to get back, essentially, are descriptions. They're going to hold information about tuples or parameters that we're going to get back from the database itself. The database might use this to indicate the names and types of attributes, or it might indicate their values with it. It's basically that result set medium that's going to come back to us. So let's look at how we actually use this connect. So this is an actual JDBC connection, for Java to connect. In this case, I'm using, I think, MySQL, and the bottom one there, the top one is a generic connection. So the idea here is that that driver manager is this environment. So if you, think about, you want to relate these to those terminologies, the driver manager, is the environment. Remember, that's manages a set of connections. We're then going to use it to get a connection. So that's what we're doing here. And we're going to set what is the connection that we're making. Now, the first thing that we're doing here is we're just saying the protocol is JDBC. And then there's going to be some information we need to provide. And we'll look at a specific example in a moment, right below it. And then once we've done that, we're also going to pass in the username and password to log in. So remember, when you create a database, you can create database users. And we said that it's good practice to create a specific user for applications connecting, right? And if we didn't, we're saying it now, but I'm pretty sure we have. So if I was to have a database, many applications might connect to it. I would want to create a user for each application that connected, and I would give that user specific permissions to only the data it needed, and the update, delete, and insert only as needed, right? And even select only as needed. So a good example is that I'm not going to give it select on my table with social security numbers if it has no reason to be in there. Like, why would iLearn need your social security number? It doesn't. It has your CWID. It needs that, which is fine. It needs to know, what classes you're in, which is fine. But it doesn't need to know your social security number. And if it did, it's a security problem, because what if somebody hacks iLearn, right, and gets your social security number, and now all of a sudden identity theft happened, right? That's pointless. So you don't even give select on the social security table to something like that, right? Now, of course, iLearn might not, directly connect to your student data. There might be another way to do it, but that's not the relevant point. The relevant point is just to kind of drive home that you should be creating users for specific applications and then connecting with that user and password. So a specific example, this is, notice where it says some JDBC vendor, we're talking about the database there. So in this connection example, it's MySQL. So the protocol is JDBC, and then we're specifically saying using MySQL, we're going to connect to localhost. In this case, this means that the MySQL database is on the same machine. If the MySQL database was on a different machine, I could replace localhost with the IP address of that machine, or possibly a DNS that points to that IP address. And then after that, I have this /test. That is the name of the database. So I'm saying on this host, find the test database. You would often have a port here as well. The standard port for MySQL is 3306. Every database has their own standard port. But if it's a standard port, you might not need to include it in the connection string. After that, as parameters, that's what we're kind of going off to when we had the question mark there. We're using a user equals, and then that second user would be the actual user's name. So, it'd be like my database user, or, usually you would name it after your application. And the password. So in this case, it's the super secure 12345, which is not the combination on my luggage. And that's a connection string. Now, you would alter this connection string for, any of the parameters we talked about before. You would, change out MySQL for a different type of database if it was something else. But this is how you can create a connection for your environment within a JDBC CLI, right? So let's look now at some of the other things that we want to do. More specifically, how do we actually execute a query? So the statement we said, right, is that individual transaction where we can send a query through. Let's look at what that looks like. The library, meaning the CLI, gives me objects like statement, result set, and these are what they sound like. The statement object is what I'm going to pass through when I want to make a query, and the result set object is what I assume that I'm going to get back. So when the CLI actually gets the data back as from the database, and it will put it into this result set, and it will give my code the result set. So the way I work with this is I take that connection that we just created on the last slide, that's the CONN there, the con, and I use a method on it called createStatement to create an empty statement. And now I use an execute query method on that statement object to pass in a query. It's just passed in as a string here. Select foo from bar, right? So we're assuming we have a table bar with an attribute foo that we're going to select. And if it had 10 tuples in it, I would get back in that result set 10 different results for the attribute foo. And that's what I would expect for this to come. And this is how I can, connect from my high-level code. You see it right here. In this case, it's in Java, to a database below. Here's a more complex example that you can use. This again is Java, and we're connecting in this case, I believe, to MySQL if I haven't changed it. And I'm here doing the same thing where I create the statement and the result set. We already have the connection created. That's not actually shown here, but we use it. So we have the create statement that we looked at before. And then once we have this statement, we execute the query and we send it through. And alternatively, we could do it with the second one here where we have the statement.execute, so obviously we didn't necessarily need the statement for this line at all, right? This actually, well, we do here. Sorry, it runs on execute query, runs on statement. But here we just have .execute, and basically, if this returns a true, then it gets the result set. This is just two different ways to do the same thing. But more importantly, what I wanted to show that was hard to do with this limited amount of text here, is that you would want to put some plumbing around this. And what I mean by that is like the try, catch, and finally. So here we have the try, which in Java basically means if this fails, if we have an exception, we're going to output the exception here, which is good because you want to know why things fail, and that'll put it in the log. A finally is something that runs regardless of whether it was successful or failed. And that's important because we have to actually close our connection. So once we create our statement, we need to finish up and close it. So we're going to both void out and null out the result set and the statement here. Notice that the connection actually did not get closed in this case. We're actually just closing both the result set and the statement. But it's important to do that, and the finally block in Java specifically is a great way to do that because that will run regardless. All right, I mentioned earlier that I wanted to talk about SQL injection, and I'm going to actually pick up here in a final video because now that we've seen how we connect, I want to right off the bat show you a specific way that you should connect before we go any deeper.